Our advisor already bought us pizza.
Okay, today we're going to do things differently. We're going to have the lecture first because I didn't give you a lecture on the mean value theorem, section 5.2, but I'm sure you guys read the book yet.
Yeah.
Very well.
F of B.
I read it in the shower.
Well, that's a very tiny part of it. Okay, let me state the mean value theorem, Boyd and Hirano, and then we'll talk about what it means. Okay, so here's the mean value theorem. Oh gosh. Sometimes we just refer to it as the MVT, just like the intermediate value theorem, IVT, right? If f is a differentiable function from a to b, I'm not going to write that part out, then there is at least one value of c here.
You're gonna have to write it down.
Write it down. If f is differentiable from a to b, then there is at least one value c somewhere between a and b, such that f prime of c is equal to f of b minus f of a all over b minus a. Now, what the heck does that mean? Let me show you. Okay, here's A and here's B. F has to be differentiable, smooth and continuous. So like something like that. Okay? Then there is at least one value of C, at least one value of C somewhere between here. C has to be between A and B now. Such that this. Now let's analyze this. What is that? That's the derivative, the slope. So the slope at C, wherever this C is, the slope of the tangent line right there, has to equal this. What the heck is f of b minus f of a over b minus a? The average rate of change, which is simply the slope of the line that connects these 2 points right there. So the mean value theorem is just saying, if you have a differentiable function, then there's at least one place somewhere in between here such that the slope of the tangent line here will be equal to the slope of the secant line here. Or there's at least one place where the instantaneous rate of change is equal to the average rate of change. Okay, bye. But that kind of makes sense, right? Because here's an example that I don't know where I read this before. But let's say you're driving from here to your house. Your average speed was 32 miles an hour.
32.
Yeah, because traffic, stoplights, and things like that, right? Your average speed was 30. I mean, it might be even less than that. Okay, whatever. 32 miles an hour. That's your average speed. Now, just by common sense, so there's at least one time where when you were going 32 miles an hour then.
Maybe not.
Just think about it.
Between 33 and 31.
Well,
But then there's at least one time
now.
to get from 31 to 33, you gotta hit 32. What if that's the intermediate value zero? Why are you trying to argue?
I don't know.
Okay, so what kind of problems can you see with the mean value theorem? Okay, here. F of x, I'll just do an easy one. Let's do a parabola. Give me a parabola.
X squared
2x squared
plus
plus
6.
3x plus 4.
4. Oh.
On the interval, give me an interval.
0.
No, let's not use 0.
Negative 10.
Negative, no, oh, you guys want to do negative 10?
No.
How about negative
Negative
1, 2, 3?
Seven.
You guys can handle 7? Okay, we'll just do it. On the interval from negative 1 to 7, what is the value? Find the value or values of C that satisfy the conclusion of the mean value theorem. So first of all, is this function differentiable? Yes, it's a polynomial. All polynomials are differentiable. That's a property of polynomials. So all you gotta do now is plug and chug. This is A, this is B, right? Here's F. What is F prime? What's the derivative?
4x.
4x plus 3. So here we go. What is F prime of C then? You plug C into the derivative and you get 4c plus 3. That has to equal to f of b minus f of a over b minus a. Okay, you guys wanted 7, now you're gonna get it. What is, so that's not equal to f of 7 minus f of -1 all over 7 minus -1. Okay, who had the 7?
Michael.
Okay, Ishihara, what is f of 7?
Wait. 123. Money.
98 plus 123 is correct?
Ooh, I'll do the bottom.
Minus f of -1,
Tiana,
that would
Hanuman.
be 2 minus 3 plus 4.
Hanuman.
3.
3, all over 8.
8.
120 over 8, which simplifies to 15. Solve this equation for C.
Wow.
4C equals 12, C equals 3.
Wait, that actually worked out pretty well.
Yeah, well, that's pretty nice.
You're welcome.
So that's the value of C that satisfies the mean value theorem. Pretty easy, huh?
Where's Trevor?
That's because I gave you a simple function here. You guys know what's going to happen, right? Going to have trig, logs, whatever I can think of. Okay, so does that answer your question for the mean value theorem?
Oh, you.
Yeah.
Mr. Parker didn't even start 5.2 yet.
Mr. Parr, I haven't even started 5.1.
Okay, now I also want to give you the lecture on 5.3 already. So we're going to table this until after. Oh, we have to! Screenshot the video then. I don't know, can you do that?
Yeah.
Okay, 5.3.
You're great.
I don't know what the title of it is, but basically, what's going on over there? We're going to be talking about the second derivative and points of inflection. Here, second derivative, concavity, and points of inflection.
Is that like a math cavity?
Cavity. Curvature.
No, there's something else.
Wait, really?
Yeah.
That's complicated.
Okay, now what did we learn in section 5.1? If the first derivative of f is positive, then what can you say about f? It's increasing, going uphill. If the first derivative is negative, then the original function is decreasing, going downhill. Right? Remember your number lines? Although I was listening before class, some people weren't even making number lines on the homework. That's your, if you don't have number lines, then you don't have justification. On the AP exam, they're going to give you like a problem that's going to be worth 4 points. The answer is only worth 1. You're going to just miss out on the other 3
25
points
is
if
the
you
garbage.
don't justify your answer. Now, is there something with the second derivative? Yeah. If the second derivative is positive, then the original function is, did anybody read ahead?
Fast.
Concave up. If the second derivative is negative, then the original function is concave down.
Makes sense, right?
Yeah, it does make sense. Okay, now let's take a look at something. Let's say you have a graph that looks like this. This is the graph of f. Is it increasing or decreasing?
Increasing.
Is it concave up or concave down?
Oh.
It's concave down. Down. Okay, look, concave up, it holds water. Concave down, it doesn't hold water.
What if you're in space?
Your grade's gonna be in space. Now, also,
high and so high.
No, it's so low that it goes to the other side of the earth into space.
It's just lost. Like
how many of you are in AP Economics? Okay, now when you have graphs like this, you guys don't say concave down, don't you say it's increasing at a decreasing rate? That's the way they do it. That's the way they do it in economics. See how look, it's increasing, the graph is increasing, but look at the slopes. The slopes are getting smaller as you go, so that's why it's increasing at a decreasing rate. That's the same thing as concave down. Right? Or what if the graph looked like this? It's increasing at an increasing rate because it's increasing, but look at the slopes. The slopes are getting bigger. So econ, you say it's increasing at an increasing rate. In calculus, we say it's concave up. Now, what about decreasing? What if the function is decreasing like this?
Decreasing.
It's decreasing. Now, what can you say about the slopes? Are the slopes getting bigger or smaller?
I can't.
Oh gosh, you guys, look. That's like what?
One.
-1, -2, -3.
Decreasing and then.
Is it getting smaller or bigger?
Bigger. Smaller.
It's getting smaller.
Oh.
So it's decreasing at a decrease. Look, -1, -2, oh, -2, -3. Those numbers are getting smaller.
So you say decreasing at a decreasing rate?
Yes.
But that
It
doesn't
looks
mean.
like it's in.
But then it's not like the decreasing is like the negative and like the
Decreasing means it's getting smaller.
Getting more negative.
Huh?
Like the speed is
It's getting faster. So
Yeah, but we're not
when you say
talking,
increase-
we're not even talking about velocity and acceleration now. We're talking about the slope of the graph.
You would still say decreasing rate? But isn't the rate getting?
It's getting smaller.
No, no.
It's getting smaller. Look at the numbers, they're getting smaller. Okay, here's the number line. -1, -2, -3. Look, I plot. Is it going to the right or to the left? Who said right? If you're going to the right, you get bigger. You go to the left, you get smaller. See, that's why on the SAT, to make the problem harder, they just make the numbers negative.
That's true.
That's what happens. Okay, so let me do a problem. In fact, I believe this was a problem last night's homework. In fact, it might be there.
All?
No, yeah.
So sure enough. Who wrote that? Who wrote all?
Wait, I almost forgot to tell you this. So if you have a graph that changes from concave down, and then right at that point, it changes to concave up, it changes concavity, you know what we call that point? A point of inflection. So a point of inflection is a point where the graph changes concavity. So you're gonna have to find these points tonight. Just like on last night's homework, didn't you find maximum and minimum points? Now tonight's homework, we're also gonna find points of inflection. Now let me ask you this, after doing last night's homework, or is that a joke?
This is a joke.
True or false?
Half joke, yeah.
If the first derivative is 0, there is a maximum or a minimum at that point. True or false? False. Because sometimes the slope could be 0, but you neither have a maximum or minimum. Here, let me give you an example. What about the graph of y equal x cubed? Look. It looks like this, right? Right at 0, isn't the slope of the tangent line 0? But that's neither a max or a min. Because look at the derivative. The derivative is 3x squared. When I plug in 0, you get 0. So just because the derivative is 0, that doesn't mean you have a max or a min. That's why you gotta make number lines. See, like if I make a number line for this, you go put 0, except it's gonna be plus, plus. Y is increasing. Y is increasing some more. See, if it goes up and up some more, there's neither a max or a min there. So just because the derivative is 0, you cannot say, oh, that's a maximum. That's why you gotta make the number line. Remember, what do we call this? This is called the
Number line.
first derivative test.
This is called the number line. That's pretty good.
So here, true or false? If the second derivative is 0, then there's a point of inflection there.
Strike. Oh, they ran.
True or false? If the second derivative is 0, there's a point of inflection there.
True.
Wrong. If the second derivative is 0, there's a point of inflection there.
True.
False! Because, okay, let me ask you this. What if you made a number line, although some of you don't make number line. What if you make a number line for the second derivative and it comes out like this? So, f is concave up, I'm just gonna shortcut it. F is concave up. Did it change concavity? A point of inflection is where it changes concavity. That's why you need to make number lines. Just because something is 0, you can't tell anything. Okay, so here, I want to do the problem I was going to do now. For those of you who did the homework, do you remember this problem? Who did the homework? Do you guys remember this problem? Okay, did we call this a classic problem? We can open any calculus book, whoever wrote, doesn't matter, whatever country, that problem is on it. Yeah, it doesn't matter. This is a classic problem because it's just too good to not do. Okay, so here's the graph. Let's just sketch the graph for funsies here. X-intercept, this is a rational function, go through the 4 steps I taught you.
Zero.
X-intercept,
Zero.
Y-intercept, vertical asymptote,
None.
none, horizontal asymptote.
Zero. Zero.
If the power on the bottom is
Zero.
bigger than the top, then it's Y equals 0. So it looks like it.
Oh, it's this one.
That's what the graph looks like.
We had that.
Yeah.
So you can clearly see, that's one absolute maximum. That's one absolute minimum. And then over here, look, over here it goes concave down. But somewhere over here, now it changes to concave up. And then right there, it changes to concave down. And then somewhere over there, it changes to concave up. Right? So where exactly are these points? Well, we need to do the calculus analysis for that. So this is what you do. First, you compute the first derivative. Who's got this? Wong, redeem yourself.
It's always one.
I don't know why.
X squared plus 1 times 1 minus x times 2x all over x squared plus 1 quantity squared.
Okay.
Ooh.
Whoa! Oh, you read it on your
Quantity
paper too. I'm impressed. Simplify the top. X squared plus 1 minus 2x squared, that's 1 minus x squared, all over x squared plus 1 quantity squared. Is that good enough to make a number line?
No.
Or do you want me to factor the top as 1 plus x, 1 minus x? Okay, whatever works. I thought we were BC, but we.
Why not?
What?
That's good.
Can't you?
Yeah, I know you can factor it, but I thought you guys can handle it already.
No.
Because you can just tell that it's 1 minus x, 1 plus x. So you can put negative 1 and 1 in the number line, right?
Okay,
let's-
the negative first.
What?
That's
Yeah,
right.
I'm not negative.
So real.
In this case, I'm not gonna.
Yes, you are.
Okay, here we go. What do I put on the number line? Negative 1 and 1. What about the
negative? The 1 becomes a negative.
It doesn't matter if you factor out the negative. It doesn't matter if you factor, no.
They wanted to cancel out the x squared plus 1.
You cannot cancel it out.
See?
You cannot, it doesn't minus.
Becomes a minus.
This is BC, people. Okay,
Not stupid.
okay, those of you who did the homework, you got this for your number line?
Yeah.
Okay, so what does this mean? And you have to write this now, I'm gonna be checking. Homework, I'm probably not gonna check this much, but on quiz and test, I'm gonna see. What do you need to write here? No,
Wait, I should
y
write that?
is decreasing.
Wait, what?
Because the function is y.
No, but
If the, I erased it. If the derivative is positive, the original function is increasing. If the first derivative is negative, the original function is decreasing.
should we try?
Now, let me ask you this, because every year it's the same thing. What if you put f is decreasing? That's wrong, because f is not even defined in this problem. It's y. And then some on the test, AP exam, they use G, H, they all use all kinds of different letters, so you gotta be ready for it. Okay, so what do I write here? Y is increasing. Y is decreasing. Look how beautiful that is. So we know now we have some kind of minimum. We don't know if it's absolute or local, but actually we do because we know what the graph looks like, yeah? There's a minimum at negative 1 comma something, and there's a maximum, some kind of maximum at 1 comma something. How do I figure out the y coordinate? You plug it back into the original. I'll do 1 half. In fact, let's just go negative half. You know how I know? No, because it's an odd function. Whoa, you ever thought of that?
No.
Now, to determine if this is absolute or absolute or local, you have to know something about the graph. Like, if this was a polynomial, and you looked at this number 9, it would look like this, right? If it were a polynomial. And then this point here would be a local minimum. However, this is not a polynomial. It's a rational function that has a horizontal asymptote. So, since we sketched the graph, you can clearly see that this is the absolute minimum, and that is the absolute maximum. So you have to know something about the behavior of the graph.
No.
Yes. Okay, now we are ready for the second derivative. Okay, now, which one of these is the easiest one to take the derivative of? Probably this one, yeah? So if we apply the quotient rule to that, Hanuman, we good? Read it off your paper.
X squared plus 1 squared times negative 2x minus okay Oh shoot. 2 times x squared plus 1 times 2 x. All over the denominator squared.
Did Hanuman do that correctly?
Yeah.
Yes, see, the derivative of box squared is 2 box to the first times the derivative of box. Okay, now we need to simplify that. Okay, is there anything that can be factored out? Yeah, I can
2x.
factor out an x squared plus 1. I can factor
Negative
out
two.
an
Negative
x.
2x.
Now, do you want to factor out a negative 2 or a
Negative two.
positive 2?
Negative
Do you have foresight?
Yes.
Negative.
Okay, then you don't. Then you want to factor out a positive.
Positive.
Oh, what?
Okay, you want to go negative?
Yeah.
Okay, pick one. What would you pick?
Positive.
Negative.
Positive.
Positive.
You
Okay,
just said
I heard-
positive. My
That's
God.
because
But
I
if you
said
actually
it. That's
did
because I
you'd
said
probably
it.
do negative.
Okay, what's left if I factor it out?
X squared plus
Negative.
Probably factor out
Negative. X squared plus 1
plus
minus
minus
2 times 1 minus x squared. All over denominator squared we go. Did I do that correctly?
Yes.
You guys gotta do it correctly.
Now we
Can I cancel one of those into one of those?
Yeah.
Okay, now simplify what's in the brackets.
Multiply it
Negative.
all out.
Now do you see why you want to factor out a positive 2?
'Cause then you
Morning
get plus x
Because the
squared.
first term will be positive.
Mr. Park, where is
Distribute.
At the 1.
So, x squared minus 3 all over x squared plus 1 cubed. There you go. That's the second
Box
derivative.
that.
Now, I'm going to tell you, you're probably going to get this on the next quiz or the next test, except we'll probably change that to a 3 or something. But now I told you that, it's going to be 4.
Now that
That'll just change the number. I just want to see if you can do this analysis here.
gonna be
Now,
7
do I need
Go
to
back to 2.
change that to x plus root 3 and x minus root 3, or
No.
can we handle it?
We can handle.
I thought so. So what goes on the number line? What makes the numerator 0? 0 and plus or minus root 3, correct? Don't forget to put the negative root 3, otherwise.
Hold on.
Fatal error.
And then, of course, the does everybody see the denominator is always positive? So
Yes.
you don't even worry about it.
Square.
Okay, so what is this number line? Is it gonna be plus minus,
Always
or
alternates.
minus plus minus plus?
Plus
It's plus minus. How do I know?
50.
Because you're the teacher.
No, it's not 50-50. Because when you plug in a number bigger than root 3,
It's
like 2,
positive.
positive, everything's positive.
And then it
But how
alternates.
do you know it alternated?
Always
Odd.
odd.
Well, yeah, that's because, see, this is x plus root 3 times x minus root 3. The first pause, that's why it alternates. Anyway, if you don't know, just plug in numbers. What do I need to write underneath to get full credit?
Why is
Why?
Y, no, this is second derivative. Y is concave down. See how I write it?
That's a waste of lines.
No, it's not. Y is concave up. Y is concave down.
You put CD.
Y is concave up. Now, I know every year the students go, Mr. Park, do I really have to write out these words? Yes, unless you have a legend. So you guys should practice on your homework. You should go, this means increasing. Although equal is a bad thing to use. This, here, let's put means then. No, let's just do this. This means decreasing. This means concave
Up.
up. And that means concave
down.
down. And then you can just go y root, y root, y root. Y root, y root, y root, y root. Okay, then you don't have to write out the
Z
words.
is equal to Y.
Now,
Which is equal to
Amachani
X.
said, can we just put CCD? Yeah, then you just go, CCD means concave down.
Can you mess with the proctor?
Channel, well, he's just so
Please don't.
Y equals X, which is equal to Z, which then
Okay, so let me ask you this.
which then is equal to
Points of
Y is
inflection.
-1.
Is negative root 3 a point of inflection, Trent?
No.
Yes.
It's a 50-50 chance. Is, when x is negative radical 3, is there a point of inflection?
Yes.
Why?
Then it's a concave differently. Right.
It changes concavity. Okay, let me tell you exactly what you gotta say. Like over here, why is this a maximal point? I think I told you last time. When we get to the 18, you don't have to do it now. but in the fourth quarter, I'm gonna make you do this. Why is there a maximum point here? I told you last time, because y prime changes from positive to negative. So using the same reasoning, why is there a point of inflection at negative radical 3? Because y double prime changes sign. How come I don't say it changed from negative to positive? Yeah, because it doesn't matter. Negative to positive or positive to negative will give you a point of inflection. Whereas this one, to be a maximum, the first derivative has to change from positive to negative. For a minimum, the first derivative got to change from negative to positive. You see the difference there? Okay, so we have a point of inflection here. What about at 0? Is 0 a point of inflection? Yes, Hirano, why?
Because y double prime changes.
Yeah! See, AB, it takes them like a week before they get it. BC, we just get it out in 1 minute.
Yep.
Are you sure it takes them a week?
Yes. Radical 3, is that a point of inflection? Ishihara?
See,
Why? Pourquoi?
Say like the letters.
the sign
What changes sign?
y double prime.
Okay. And then how do I get the y coordinates? You plug it back into the original. Okay, I'll do 0. Who's got radical 3? Choi, plug in radical 3.
Radical 3.
Ooh. And then negative radical 3. Angelo. That was fast. There you go. I believe this is also a problem. See, last night's homework, this was the problem. And then on tonight's homework, this was the problem. I did one of the problems for you. Nobody dare, you guys better not dare put it on the list. Whenever the next time I see you.
so true though.
Okay, now, that's the lesson for today. Oh! No, there's one more lesson. Now, so far, what is the only way to justify a maximum or a minimum value? By doing the first derivative test. However, if you read the book, there's this thing called the second derivative test. Okay, let me tell you what that is, and then we can discuss the homework.
Graph it and
Can we discuss the test?
No, I didn't blow it though.
Let's go over the test.
There's a lot of germs there.
If the second derivative, no, sorry. If the first derivative is equal to 0, and the second derivative, no, I should put A. If the first derivative at A is 0, and the second derivative is positive, then what can we conclude? Then what? There is a relative blank at x equal A. Fill in the blank. Think about it. If the slope of the tangent line at A is 0, that's the slope of the tangent line, so horizontal. But the second derivative is positive, which means the graph is concave up. What would that be? There's a relative minimum at x equal A. This is called the second derivative test because you gotta compute the second derivative. If the first derivative at A is 0 and the second derivative at A is negative, you can probably guess there's going to be a relative maximum at x equal A. Why? Because look, if the slope of the tangent line is 0 and the second derivative is negative, which means f is concave down, then that's the maximum point. This is called the second derivative test. So right now there's two ways to justify a maximum or minimum. You can use the first derivative test or the second derivative test. Use whichever one is the most convenient. I would say over 95% of the time you're going to do the first derivative test. Just in rare cases, here and there, you might use the second derivative test. But they're definitely going to test you on this on the AP exam, so you better be ready for it. All right, enough. Let's go over the homework.
911.
Okay, but before we do the homework, so are we really doing all?
Yes.
All you have to do is do this right here on every single problem, and that's how you do it. Every single problem is done just like this. You take the derivative, you make a number line, you write down your answers. That's all you have to do, every single problem.
Will you actually do all of them?
No, we will not. This is BC.
Then what you do
Okay, yeah,
option?
now the test is going to be on Tuesday, so you know what? Before I even do that, I wrote a problem that's going to help you. Right here. Y equals 9/2 sine inverse x over 3 Because I don't want to shock you out of oblivion on the test.
You wrote.
Yeah. Compute dy dx. I wrote this problem. See, this is how I write problems. So, hey, Mr. Park wrote this problem. The answer will come out pretty nice.
You ready?
So if you come up with this monstrosity, probably that's not it. Unless I wrote it to keep you honest.
The answer's like 5.
So make sure you get the, now I know some of you, your algebra is
No, it's gonna be
questionable.
one turn.
Yeah.
So that's why, make sure you get half the points for the correct derivative. So, let's just, who's gonna do the first term? I'm looking on that side of, Abe! First term, just this one right here.
9 over 2.
Read it off your paper.
We didn't do this.
How much paper?
What is it?
That's a joke.
One.
This is true.
Oh, 1 over square root of 1 minus x squared over 9 times 1/3.
Oh, that
Ooh,
is
yeah.
beautiful.
Write it off on paper.
That's how, okay, who's got the second term?
Why do you get that?
Uh-oh. Hui. 2, no, Hui 2, yeah, Hui 2. What do you want to do with this 2 here?
Leave it on the bottom.
Really?
No. Yes.
Well, that's the same thing as throwing it on the side, but you want to throw it on the bottom.
Yes.
That's mean.
Throw it
Throw
on
it
the
on the side, at least that way it has a chance of coming back.
Okay.
Whatever, then.
9 minus x squared quantity to the half.
Okay. Go ahead.
Okay.
Plus x times 9 minus x squared to the half.
No.
What? Oh,
The
oh,
derivative
oh,
of
wait,
it.
wait, no, never
One
mind.
half.
Okay. I don't know. Calm down.
That's to the 1/2 power, right?
Oh, 1/2
Oh.
that thing to the negative 1/2 times 2x.
No.
Negative 2x.
Yes. Okay, I'm going to tell you right now. See, that's a common mistake. They put positive 2x instead of negative 2x, and then it's not going to come out nice. You're going to get this monstrosity. Okay, right there you get 3 out of 6 points. Now, I already told you on the test, like, how many of these do you have on the practice test? Did you guys at least look at it? There were 5 or 6 of these.
Yes.
4.
I think, so on the test, I think there's going to be 4 of them about this level right here.
So long.
Okay, you got 3 out of 6 points. Now we want the other 3. Simplify it.
Super fun. What is?
This goes into that 3 times. So 3 over 2 times 1 over root. Now what do you do
9
when you
minus x
see a
squared.
fraction? You make a least common denominator. What goes on the top? 9 minus x squared. Hey, but this 9 can come out of the radical as
3.
a 3.
Then it cancels.
Wait.
Oh.
No.
3 goes on.
No,
It's just
Moose
on the
bread.
bottom.
No, it doesn't.
No,
Mine.
it doesn't cancel.
Mine. It was a more
Because that's
than
like
yeah,
multiplying by the,
more
that
than
3 does not cancel that 3. See, that's not good. Minus 1/2. Okay, now what do we got here?
Morning
We got the square root. Now, if you have trouble with fractional and negative exponents, I would suggest change it back to radical. Whatever you need to do. This 2 cancels that 2, and so you're going to get minus x squared over root 9 minus x squared. Did I do that correctly?
Sure. Yes, you're the teacher.
Yeah, finally you're getting something.
Oh.
So let's simplify. 9 over 2 root 9 minus x squared minus, see, I can do this. You guys got to do this. 1/2. Now, what happens when you add subtract fractions there? You make a least common denominator. Okay, tell me what goes on the top. Lamachane.
9 minus 9.
9.
No.
See? See?
Oh, wait. Minus
9 minus x squared minus x squared. And then cancel the x squared.
Yeah. So you get 2 minuses, which makes a plus.
So what do we got here? 9 over 2 root 9 minus x squared minus 9 minus 2x squared all over 2 root 9 minus x squared.
Oh.
Oh! Hey, that's the same denominator. 2 over root 9 minus x squared. What goes on the top? 9. Don't forget this minus sign got to be distributed over here. minus 9 plus 2x squared. Cancel, 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 cancel. X squared over root 9 minus x squared.
Oh,
Hey, that looks like a problem Mr. Park would make.
Why doesn't even look nice?
And you know how I make these problems? I start
You
with
go
the
backwards.
answer, and then I go backwards to get this.
Is that
And Yoshida, how do I go backwards?
antiderivative.
Yeah, I just find the answer. So I get whatever I want my answer to be, and I just take the antiderivative of it. It's like the reverse of the derivative. We're gonna learn that. So you're gonna actually be able to do this in
Third quarter.
around Christmas time.
There's a homework on 5.2 that said find the antiderivative.
Oh, yeah. Actually did.
Yeah, we did that in PCH too, right?
Oh, yeah, yeah.
Yeah, we did.
We did.
Okay, that's what I wanted to show you. So you guys better be ready for things like this. It's not gonna be simple. I want you to simplify. It's fun simplifying. I have fun.
No.
Okay, we only have 13 minutes left. So let's start with section 5.1. Let's do as much as we can. Okay, what's the first number from 5.1?
11.
11? Where's 11? Boo! Okay, let's do 11. Isn't that like one of the beginning problems?
Yeah.
Hey, you know why I assigned this problem? I recognize it. It's from the AP exam. I recognize it. Come on, I've been teaching this for 30 years. I see the AP exam problems. Okay, what are you thinking when you see they give you a restricted domain? No, these are endpoints. Remember, endpoints are also critical points now. So endpoints are going to be maximums and minimums as well. So first thing, we need to compute the first derivative. Who's got this? Who we won? No need to read it off your paper, just look up here.
Negative 1 minus x over x squared.
I don't know. Ooh, so you're doing it all at once. You're doing it and simplifying it. That's amazing.
Yes.
I can't do that. Plus 1 over x, so you make a least common denominator. X, is that what you said?
Yeah.
Oh, see? You guys can do stuff in your head.
Wait,
Read it off your paper. Make a number line. Woo! What goes on the number line? 0 and 1. Think of a number bigger than 1.
2.
Plug it in.
1.5.
Positive over
1.5,
positive is
yeah.
positive. How do I know it alternates? Because that's an odd power. Or how about plug in 1/2? And then we don't need to test that one. Somebody tell me why.
Because there's the.
Kaneshiro, why don't I have to test the number over there?
Oh. Because it's not in the range.
Okay, what if they didn't have the range there then?
Then you probably have to.
No, you still don't have to. How come?
Oh, because the natural law.
Because when you have natural log, the domain of natural log is x is greater than 0. So if you were to graph this, there is no graph to the left of the y-axis. You gotta think of things like that. Okay, so what do I write here? Whose turn is it? Moriguchi, what do I write here? Tell me what to write. F is something. Okay, but I had my legend. Remember the legend that got erased? No, I had the legend. It's on the top of my homework, so I can just do that.
Fatal error.
I have my homework. It's in the, what do you call that? It's in the
Sonic space.
the sky.
It's in the speed force.
What do I need to write here, Moriguchi? F is increasing. Hey, that's a minimum point here. So I have some kind of minimum point at 1 comma something. How do I find the y coordinate? You plug it back into the original. Who's plugging in?
I'll plug in the first
Huang.
one.
Huang. Baby.
1 plus 0.
Which is 1. Now, is this a local minimum or an absolute minimum? Lee, local or absolute? Very good. Why? Why would that be absolute? How do you know that's the lowest point on the whole graph?
I checked the back of the book.
Wait, I'm trying to calm down. No, just think about it. If a graph goes down, and remember there's endpoints over here, so it stops over there and it stops over there. So if you have a graph that goes down and then it goes up, and that's all it does, Isn't that the lowest point on the entire graph? So it has to be an absolute. Now, we have endpoints over here. So both of these endpoints are maximums. Can you see? But, okay, now, both of these are maximums. Okay, so at 1/2 and at 4. How do you figure out if it's absolute or local?
Plug it in.
You have to determine which one is bigger, right? So we have to plug it back into the original. Okay, plug in 1/2 into the original. Angelo?
Oh, okay, let's see. 2 plus ln half. Oh, wait.
Yeah?
2 plus, 2 minus ln 2.
Whoa! Angelo, your stock is rising.
Oh.
Can somebody go downstairs and make the graph go up?
Yes.
Everybody see what he did?
No.
2. Okay, he plugged it in and he got 2 plus natural log half. But isn't 2, 1/2 the same thing as 2 to the negative 1? And he put the number in the front and he impressed me. Angelo! He impressed me. And everybody, look, most of the people going, so I do that on a daily basis, right? Okay, who's plugging in 4? Let's look at this side of the room. Olga, plug in 4. Oh, you impressed me.
Huh?
Instead of writing ln 4,
Oh, 2 ln 2.
Oh, Ricky.
wait. Are you like the Phantom of the Opera? You're sitting here, but I heard your voice from back of the thing. Whoa, that's amazing. You guys understand why natural log 4 is 2 ln 2? I'm telling you right now, this is how they test to see if you know your properties of logarithms on the AP exam.
Wow,
You're gonna get ln 4, but you're gonna look through the 4 answers. I don't see it there, because they changed it to 2 ln 2. Now, without a calculator, how do I figure out which one of these is bigger? Who? Impress me. Wait, are you in AP Chem?
Yeah.
Okay, then you know. Impress me. How do I, without a now anybody can punch it in on their calculator and figure it out. But without a calculator, how do I know which one is bigger? Impress me. That's because anybody who takes AP Chem knows natural log 2 is approximately, who?
1.
0 point.
No, you don't have to say 0. Just go point
I don't know.
693. What?
What?
Whoa.
Oh yeah.
I'm gonna remember this
The
number.
half-life of
Wait.
Yeah, whenever you took chemistry for the first time, didn't you guys do half-life?
Yeah.
Half-life?
Yeah.
We didn't memorize anything.
Yeah, but then you see 0.693 so many times, you just know it already, right?
But that was like 2 years ago.
No? Okay, what about AP Chem?
wasn't regular.
We're not there yet. Okay, how about PCH when I told you this?
I would have remembered if you told us LN2 was 0.6.
Okay, even though we're BC, we'll just go with 0.7. We'll just go with 0.7,
No,
okay?
that's just 3
What is
decimal
2?
accuracy.
2 minus 0.7.
1.3.
1.3. 0.7 times 2. 1.4 plus 0.25. 1.65.
5.
Which one is bigger?
4.
That one is bigger. So this is the absolute maximum, this is simply a local maximum. See, there are certain things that are expected of you when you're in BC.
Okay, I'll
Knowing natural log 2 is 0.693.
0.69.
How about 0.7?
No, 69.
Hey, just remember it's a, nah,
I'm
I'm not,
gonna just say,
just go 0.7.
how about 2 decimal accuracy?
Okay, we're done with that problem.
Wait, Mr. Park,
Yeah.
what
I'll
about
go every time,
56
just say
on
LN2 now.
5.2?
Wait, we gotta get through 5.1 first, Yoshida. Look at this. You see that? And next, okay, if you're gonna write all next time, please don't write it like that. Write it like this. Because of the 911. See? Oh, 911. I need help. And of course, the next question is, where were you this morning? I come at 6. Today I was actually here at 6 o'clock. Nobody. Just deserted.
So you wouldn't get
Called you over and like, oh,
Okay, we got time for one more. See how long it takes to do one
28.
problem, people?
Wait, 56 is
28.
good. It's really good.
It's really good.
I can't figure it out.
Therefore, it's good.
Oh,
Oh, okay, wait. Okay, somebody
It's good.
give me another question for 5.1 first.
28.
28. Okay, I'll do that one.
Hey.
Yoshida, you're just gonna have to wait.
You gotta come in tomorrow.
Wait. Oh no, don't come in at lunch, you're going to McDonald's.
Can you take us with?
No, I'm easily influenced. Every time I see one of those commercials on TV, like Arby's, we have the meats. Oh man, I just want to go to Arby's, except it's in Waipahu.
Just go to McDonald's.
Like right now, you know the commercial for Arby's?
It's in Pro City.
There's one in Pro City?
Pro Ridge.
In Pro Ridge?
Yeah.
Oh, I haven't been to Pro Ridge like this for 20 years. Come on, I live in Kaneohe, man. Where on the second floor?
Somewhere.
I don't even know. Isn't there like a
No,
top
not
and
the
a
first
bottom
floor.
part?
Yeah, it's the top part.
Yeah, the second floor is the
Yeah,
top
it is.
part.
Because the commercial had the crispy chicken
Yeah.
with the pepperoni and
Oh.
the Parmesan cheese with the red sauce.
Yeah, but in those commercials, that's not actually food. It's all-
I love Arby's.
McDonald's,
They do.
but
Oh,
there's a-
Ishihara, you asked for this question. Was there a restriction or is this it?
I don't write
No
that
restriction.
down.
No restriction.
Okay, so that's it. Okay, here we go. Take the derivative. I'm looking at this side of the room. Who? Redeem yourself. Derivative.
6x to the third plus 12x to the second minus 18.
Factor out of 6x.
Stock is
X
going
squared
down.
plus 2x minus 3.
It's a
Should I use
maximum.
quadratic formula?
Yes.
Resist the urge and
It's a
factor.
global maximum.
Resist the urge?
No. In AB, I just graded a test. They get that. They do in quadratic
It's so much easier.
Makes sense.
I would say that, right?
I'm pretty sure your algebra teacher taught you, you factor it first. If you cannot, then you use the quadratic.
What if you
X squared minus 4ac.
No, it's.
Okay, now what if you couldn't see the factoring, but you did quadratic formula, then doesn't the inside of the radical come out to a perfect square? And then you go, darn, I could have factored it.
Yeah.
Yeah.
You don't know that.
Plus, minus, plus, minus. Y is
It's a
decreasing,
concept.
Y is increasing. I'm saving time because I had the legend, see? You have a legend, it saves time. So there's some kind of minimum there at -3. There's some kind of maximum at 0 comma something, and there's some kind of minimum at 1 comma something. How do I find the y coordinates? You plug it in, I'll plug in the 0, 10. Who's gonna plug in 1? Okay, that one's kind of easy. Who's got the 1? Owen, plug in 1.
Boy.
I'm trying to do it in my head. Plug in 1.
Oh, I got it. 13
Yeah, that's what I got.
Oh, thanks for,
Is that correct? 13 halves? We get it correct. Now who's got the -3?
Oh boy.
oh.
Yoshida.
Negative 16.5.
Oh!
That's not it.
Is that not it or
No.
That's wrong.
That's not.
Shh, I'm trying to concentrate. -3, 81, 243 halves, plus, minus,
Negative 57.5.
108, minus, we're plugging in -3, yeah? 54 plus 10. Negative 162 plus negative 152, 243 minus 304, negative 61 over 2, is that right?
No.
57 plus 4?
No.
What did I do wrong?
54 is 9, never mind. Isn't 9?
We don't know what you did.
What did I do?
You made a common denominator.
This would be 40.
It's 81, right?
Wait, this is negative 162 plus 10 is negative 152, right?
Wait, you're 54.
It's not 54. What?
81.
Nine times.
This is 81.